got two presentations today. A case study on fear, impact of PFOA on water contamination, environmental risk, county level population change by Sam Taylor at West Virginia University. Dave Shideler will discuss that for us. And Katie Welch, Oklahoma State University, is going to discuss or talk about her research on economic contribution and impact analysis of the 2019 flood disruption on the Oklahoma-McClellan-Kerr navigation system. And Kelsey Conley of the University of Idaho is going to be talking about that with us. First, I want to go over and tell you that this presentation is being recorded, and the presentations will be posted on the SRSA YouTube channel as well at srsa.org. We have some interactive features in Zoom webinar. If you're not familiar, you can post questions. You can interact with us by raising your hand, typing in chat, or typing in Q&A. And we ask that you ask questions after the presenters have completed their presentations. If you haven't chatted in the Zoom webinar, just click the chat button to open the chat panel, type your message in the text box at the bottom of the panel, press enter, and we'll be able to see that. Okay, and asking a question in the Zoom webinar, you can this is the second way you can do it. Click the Q&A button to open the window, type in a response to the question. And if you want your questions to be anonymous, you can check off anonymous and then click send. So we're going to reverse order here today and start out with Katie Welch first, and she's going to talk about flood disruption in the McClellan and its impact on Oklahoma's economy. Katie, it's yours.
All right, let me share my screen.
And Dayton, you might need to stop sharing in order for Katie to share hers.
I do.
There we go.
All right, can everybody see that?
Yep.
Yep.
Perfect. So this project is the economic contribution impact analysis of the 2019 floods disruption of the Oklahoma-McClellan-Kerr navigation system. I'm Katie Welch, like Dr. Lambert said. I worked with Dr. Alicia Lambert and Dr. Dayton Lambert on this project at Oklahoma State. Just a little background, the MCARN's construction started in 1957. It was completed in 1970. It ends at the Tulsa Port of Catoosa. You can see that it was just circled in purple. And the point of the MCARNs was being built was to open up shipping from the Mississippi River, which is down at the bottom right corner of the screen, through Arkansas and Oklahoma. And this project is going to focus on the Oklahoma section of the MCARNs that's just been boxed in with red. The Tulsa Port of Catoosa is actually an international inland port. I didn't realize there was an international port in Oklahoma, so that was a really interesting thing to me to learn about. But the TPOC serves the economies of 12 states. Since 1971, over 86 million tons have shipped through the port, and it is connected to a 25,000-mile inland river navigation system, which you can see in the blue lines. And since it has access to the Gulf of Mexico, it actually can ship worldwide. During a normal year, 1,000 barges pass through the port. So it's really a big port, I mean, for an inland port. And like I said, I didn't realize it was there. It was really surprising for me to learn that. So the primary commodities that normally ship through the Oklahoma MCARNs, as you can see from these visuals, are chemical fertilizers, soybeans, iron and steel, grain, some other things like that. So it's really heavily agricultural industries and manufacturing industries. And so what happened was in the spring of 2019, there was some historic flooding. They were calling it the 100-year flood because there hasn't been flooding like this in 100 years. And it occurred throughout Arkansas and Oklahoma. It ended up closing the Oklahoma MCARNs for 140 days. And as you can see from some of these headlines, it caused a lot of concern and questioning about how long this flooding was going to last, what kind of economic loss this was going to result in, and just how this was going to be for businesses and industries in Oklahoma. So that leads to some questions. What is the economic contribution of the Oklahoma MCARNs? And then what economic impact did the flood disruption of the Oklahoma MCARNs and the Tulsa Port of Catoosa have on Oklahoma's economy? And did the disruption have a different impact on metro and non-metro economies? So one way to analyze this is with input-output modeling, and input-output modeling is founded on export-based theory, which says that a region produces some good or service that is demanded outside that region, and that generates income. And then input-output modeling extends this theory to sales. So sales bring income into a region, and that income creates a multiplier effect when it's respent locally, and the size of that effect is determined by rounds of local purchasing. So some assumptions and limitations for input-output modeling is that it has perfectly elastic supply. So your output's going to adjust to meet all changes in demand. There's constant returns to scale. So if you double your inputs, you'll get double the outputs. And it has a fixed input structure, so you can't substitute between inputs. And so all of these kind of work together to make input-output analysis work really well for short-term analyses, but not as well for medium or long-term forecasts. Our multiplier effects, there's a couple different ones. So you have your direct effects, and those are your initial effects to an industry due to some event. You have your indirect effects, which are your business-to-business purchases, and then your induced effects, which is the household spending of labor income. And then any money that leaves the region is a leakage. So we're going to be using MRO in this project. That's multi-regional input-output. And like a traditional input-output model, MRO tracks the interdependencies between industries and an economy. But the difference is you have these linked regions. So the direct effects in one region can trigger indirect and induced effects in nearby regions. So you can kind of see in the visual how a single region, you have your effects within the region, and then anything that leaves it is a leakage. But when you have multiple regions, you have those same effects, but you also have effects that can be traced into your additional regions. And then you'll get some indirect and induced effects in those regions, some leakages out of those regions, but you'll also get these feedback effects into your first region. So backward linkages, what are they? Backward linkages are the supporting sectors for, in our case, the Oklahoma-McClellan-Kerr. So these are inputs for their businesses. So you can see they're the red sectors in this diagram, and they kind of make sense. You've got your financial and your insurance industries, gas and oil, utilities, services, and that kind of makes sense because they're supporting the Oklahoma-McClellan. And then your forward linkages, they're the downstream sales of water transportation services to other industries. So again, they're in the red, and they include some things like ag inputs, gas and oil, manufacturing, truck transportation, construction, those things. For this project, we of course need data. We're getting regional data from M-Plan, and then cost delay data from the impact study that was done on the MCARNs by Robinson in 2014. And we're getting some tonnage figures from the 2018 Inland Waterway Fact Sheet produced by the Oklahoma Department of Transportation. M-Plan has 546 different industries, and that can be a little bit bulky to work with. So we of course want to aggregate that down into a more manageable number, but we want that to reflect Oklahoma's economy. And so over half of Oklahoma's economy is comprised of ag, mining, construction, manufacturing, and trade, transportation, and utilities. Those are what the industry aggregations are really going to reflect. So these are the industries that we have chosen. And as you can see, some of these, which might normally be boxed together under agriculture, have been disaggregated. So we can look a little more closely at those different sectors. And again, like natural gas and petro and mining are two separate ones instead of just under mining, because natural gas and petroleum has such a huge part of Oklahoma's economy. And then so we have decided to go by congressional district. The MCARNs is mainly located in District 2. And part of the point of this is so we can show how the MCARN support of Catoosa is economically important to the other districts in the state. And this actually allows for some detailed information for each district. And that's really, if anybody wanted to know it for policy reasons or anything like that, they would have access to something that's pertinent to their district. So this is a depiction of how the MRO is going to work with a 5-region model instead of a 2, like you saw in the diagram earlier. So we have our flood disruption, and like I said, most of the MCARNs is located in District 2, so that's where our direct effects are going to go. And then our induced and indirect effects are going to be in all those regions that are connected. And then we get feedback effects from all those regions again. And this will keep going until all of the effects have leaked out of the model. So the contribution analysis, what does the existing activity that MCARNs contribute to the economy? We determine this by examining the sales and purchases as forward and backward linkages to the water transportation industry, since that's the MCARNs, and since really the only water transportation industry in Oklahoma is the Oklahoma MCARNs, that makes it pretty easy to isolate that. So we restrict the RPC to 0, and that removes buybacks within the industry. And you can see from the chart at the bottom, it ends up with having an employment of 38, an output of about 9.5 million, and a value added of about 2.1 million. And while that may not look very impressive on maybe a state scale economy, when we look at the multiplier effect, we can see that the Oklahoma MCARNs has a multiplier of 2.10, and that means that $1 worth of activity on the MCARNs leads to an additional $1.10 in other parts of Oklahoma's economy. And this is huge because they're producing more in other parts of Oklahoma economies than they have existing within them. And you can see most of your other industries range anywhere from 40 to 60 cents, with the exception of mining. And this is kind of because the Oklahoma MCARNs, as a water transportation service, it's supporting the supply chain of your other industries. So it's creating more, that multiplier is creating more effects in some of the other industries than you just straight out see in the water transportation. So if we break down that contribution by industries, if we really want to see where that employment is, we can look at that first chart on the left. So the direct employment is, of course, in your water transportation industry, but you get that indirect and induced employment in services, government, your financial services, and your other transportation. And then it's the same for output and value added, just with different industries. So in output, you have water transportation, your financial, government services, natural gas, and petroleum. And then for value added, you actually don't see water transportation here because you have more value added in your indirect and your induced industry. So that would be your government, financial, again, services, natural gas and petroleum, and wholesale. For the impact analysis, we're trying to determine what impact the flood disruption of the MCARNs had on the economy. So it's kind of a twofold impact because we have the complete closure of the MCARNs, the Oklahoma MCARNs, for 140 days. And then we have the delays to industry shipping commodities through the MCARNs. So the way we're going to do this is we're going to run a series of scenarios for a 2, 4, and 6 month closure with upper and lower bounds. And we're going to achieve those upper and lower bounds by running a scenario that has the RPC restricted to 0, and then running the impact scenario again, allowing internal adjustments by M-plan. And the RPC 0 scenario is going to be the lower bound, and the other is going to be the upper bound. To calculate the shipping delay cost for our different commodities, we're going to multiply delay costs from the Robinson report by the MCARN's tonnage. And we're making an assumption here that if there's a 2-month delay, then there would be 2 months of tonnage delay. So essentially the tonnage delayed is the equivalent to the length of the delay. So for a 6-month delay, there would be 6 months of tonnage delayed. Then we're going to aggregate our MCARN's industries back into our model industries, shock the industry by the findings from step 2, and then do this for each industry experiencing delays. So these would be the delay cost per ton of commodity, like I was talking about. That's part of our first step. We're going to multiply these by the tonnage, and that's what we get here. So you can see that these disruption shocks are in millions of dollars, so some of these are really big numbers. And then the next thing we're going to do is we're going to aggregate these back into our model industries. So iron and steel, manufacturing equipment, machinery, and other chemicals would all fall into manufacturing. And we're going to do these for each of the commodities listed in this chart. And so that's going to end up looking something like this. We're going to have 9 different disruption impacts. One on oilseed farming, grain farming, natural gas and petroleum, mining, food manufacturing, ag inputs, water transportation, and manufacturing. So that's going to shock the economy, and we're going to get changes in jobs, output, and value added. And what that ends up looking like is for our 2-month disruption scenario, we're going to have a range of 140 to 150 jobs, supported jobs lost, 25 to 27 million dollars lost in output, and 7.8 to 8 million dollars lost in value added. For 4 months, it goes from 627 to 668 jobs, 100 to 106 million dollars in output, and 21 to 23 million dollars in value added. In our 6-month scenario, it's 1,437 jobs to 1,531, 217 to 233 million dollars in output, and 37 to 40 million dollars in value added. This is the same information. You just see the columns have average. They don't have a range anymore. It's just the average. But it really shows you how dramatically it increases in between your different scenarios. So it's more than double from your 2 months to your 4 months, and then again to your 6 months. So it's not just, well, it increases at whatever rate. It's actually increasing quicker than, doubling. And then if we break this down by industries, like we did the contribution analysis, we see that for employment, most of the jobs are being lost in mining, and then services, grain farming, government, and miscellaneous. In output, it's your ag inputs, oilseed farming, financial industries, services, and manufacturing. And value added's a little interesting because we have mining there, and they actually have a positive value added. I did a little digging into this, and it has something to do with their other property income. Because they have a negative other property income, when you put a negative impact on it, it actually increases their value added. I'm still looking into that so I can figure it out more, but we're gonna have to look more at that industry in depth. And then of course we have oilseed farming, financial services, and ag inputs. So to figure out how this is different in our metro versus non-metro, we're just going to divide it up by districts. So metro would be 1 and 5, non-metro would be congressional districts 3 and 4. We're going to filter by the districts, aggregate the results, and then compare them. So what we find in employment is that most of our employment lost is in our metro areas. The metros in blue and the non-metros in orange. This is again by months, so you go from 2 to 4 to 6. Output is much the same. Again, most of the output is lost in metro areas, and value added again is in the metro areas. So to sum this up, the Oklahoma MCARNs contributes a total value added of $2.1 million to the Oklahoma economy, but $1 worth of activity on the Oklahoma MCARNs results in $1.10 spent elsewhere in the economy. The total value added lost from the closure of the Oklahoma MCARNs ranged from $24 million to $64 million, depending on how long that delay duration was. And some industries that experienced the highest losses include oilseed farming, your ag inputs, government services, and your financial industries. And so what's next? We want to estimate these losses due to the closure of the Oklahoma MCARNs in the surrounding states. Some of these being Arkansas, Kansas, and Colorado. We also want to take another look at some of our industry aggregations. We put iron and steel into manufacturing, but some of that probably honestly went into construction, so maybe we should divide it up differently. We also want to look, maybe we should combine District 1 and 2, since part of the MCARNs in Tulsa, Port Catoosa is in Tulsa, and run those scenarios again. And then we also want to look at some of the results we found in more in depth, like what's going on with mining, why did their value added actually raise? So that's what we're looking at, and that's all I have for you.
Great, thank you, Katie. Next, Kelsey Conley will discuss Katie's research. Kelsey?
Hello.
Hi.
Well, Katie, I thought you did a really good job with the paper. I know a lot of input-output analysis deals with assumptions that are made about the model, including possible upper and lower bounds, and then the 3 time periods that you ran it. And so I thought that was a really good idea, because that kind of shows the different, the range of the values that you can get. And again, I think some of the assumptions that you make in the models definitely impacts the values that you get from the models. And I think one thing that I would be interested in is you talked about combining districts 1 and 2. I would also possibly be interested in the different metro and non-metro combinations. I think the idea of the districts is a good idea, like congressional districts, but I would also be interested in, like, you see a lot of the impacts in those metro areas. So I'm assuming a lot of that's dealing with the indirect and induced to the services and financial areas. But I would also be interested maybe in kind of maybe identifying those areas in different ways. So maybe, like you said, combining regions 1 and 2, or maybe looking at county levels. I know that might take a long time, but maybe looking at like mining dependent counties or different industry dependent counties, and maybe seeing how those are affected. Because I think in some of those congressional districts, there are metro areas. And so I'd be interested in that too. But overall, I think it was a really good job and an interesting case study sort of on what happened last spring.
Thank you. I think that's a good idea about looking at some of the different ways we can analyze the metro and non-metro results. I appreciate that feedback.
Okay, are there any questions? You could use, apparently we don't have the Q&A feature enabled today, so just use the chat feature if there's any questions. Okay, if not, then we'll go on with Sam Taylor. Sam, take it away.
All right, guys, let me get up and running here. All right, let me know if that isn't visible to folks. So good afternoon, everybody. My name is Sam Taylor. I'm at West Virginia University. The title of my talk today, Case Study in Fear, the Impact of PFOA Water Contamination and Risk on County Level Population Change. So to start with, what is PFOA? Perfluorooctanoic acid, and you can see why we shorten that for talking about it. It's also known as C8. It was developed in the 1940s and is a constituent chemical in a lot of non-stick cookware. It's typically thought of in use in Teflon and Scotchgard. It's a chemically and biologically pervasive chemical. It has a long half-life in the environment, and it's advised that you shouldn't drink it at this point. One of the things that's sneaky about PFOA is it doesn't make water unusable in a classic sense. It's odorless, colorless, and tasteless. Especially at the concentrations we're going to talk about in this incident. So the study I'm doing today centers around the Washington Works plant near Parkersburg, adjacent to the Ohio River on the border of Ohio and West Virginia. Parkersburg's in West Virginia. And we put spill around in quotation marks here because it was intentionally released into the environment through landfilling and air emissions. So spill's a bit of a euphemism. In 2005, the EPA fined DuPont $10.25 million for violations. Those were the largest fines in agency history at the time. And concurrently, a class action settlement in 2005 and 6 was levied against DuPont for $107 million. Part of those funds were used to establish a C8 science panel, as it's called. And that science panel investigated the health effects of C8 on folks in many counties, actually the counties we have highlighted here. It eventually linked exposure to PFOA to multiple diseases with the final findings released in 2012. So our study looks at counties included in the C8 science panel research, 5 directly impacted counties where there was definitely spillage or it's been detected in these water districts, and then 5 other counties that are in the surrounding area. So our research question is, did this large-scale, long-term water system contamination lead to long-term population loss from these counties? And we're going to investigate this using a synthetic control approach. Some of the strengths for this is we have data availability for long pre-treatment effects. We develop a donor pool that excludes next door counties to our treated counties. In this case, the PFOA impacted counties are the treated counties. We exclude their next door neighbors, and counties in West Virginia and Ohio from our matching. We also found some interesting effects from counties in Louisiana due to Katrina in this time period, so counties from Louisiana are excluded as well. So to generate our donor pool, we generate two different donor pools. One is using a nearest neighbor type matching approach, where we look at relevant county characteristics such as income, unemployment, industrial compositions, population density, as one set of donor pools. And then for a robustness check to just make sure our model is specified in the right way, we also use a randomly selected pool of counties and run the same models to the same specifications, with the idea being there that if we have the model reasonably specified, those models should be relatively consistent. So we then use the synthetic control to directly forecast populations of the treated counties versus their untreated synthetic control. And we use population ratios for each county compared to 1990. This allows us to compare between counties with different population levels. So a quick run through in our approach. This is a bit of background just in synthetic control. So the synthetic control county is evaluated using a difference in difference approach. If this figure is positive using the delta TR formula you see there, if it's positive, then there appears to be an effect and we'll continue to analyze the county. If it's negative, then we can say there's no response in response to the treatment and the county falls out, there's no effect. To verify the robustness, we then run again that same analysis using our nearest neighbor counties and our randomly selected pools and a couple different alternate model specifications. If those scenarios don't agree, then we probably have a misidentification in the model. And so what I show here is in the chart in the lower right, in the second step, these gray lines all stacked on top of each other are multiple model specifications using two different donor pools, with the black line as the actual population. This is for Washington County, Ohio, just as an example. Then in the final step, we do a placebo testing. This is again sort of conventional for synthetic control. It involves the creation of the synthetic match for that county, and then you compare it to the counties that were donated to create the synthetic control. And if you find a significance, basically if it's a highly ranked in that group, you can start to say that you have a significance, the effect is real versus just a random effect unrelated to the water contamination through the selection of your donor pool. So the big issue that we had to address in this study is that there's an extended potential treatment time. In normal synthetic controls, there's a clear before and after, typically the passage of a new law or a natural disaster. And here we have a clear before. There's before the EPA fines and the class action settlements, and there's a clear after with the release of the PFOA or the C8 science panel findings that link the chemical to health effects. The problem is there's a 7-year period in between them where communities have imperfect information. The large settlement in 2005, 2006, the $107 million was publicly known, but outside of the big water districts, who was included in that settlement was not. Many settlements to private parties were not publicly disclosed, so there's likely a community information of these effects. And so that leads to our main problem we're going to have to address here, which is how do we address and identify the treatment time? So the first pass we made was to better identify treatment time. I use a simple scoring metric. We run all 10 counties through the synthetic control using each potential treatment year from 2005 to 2013. Then using that difference in difference, we look for which ones have a positive effect and which did not. 2 counties had no years with a robust result, and they follow the analysis. For the remaining counties, we seek a combination of highest difference in difference and lowest mean squared predictive error. Basically, that says that you have an effect that's notable and a good pretreatment fit. And what we find is all of those highest scores for the 8 remaining counties occur early in the treatment period from 2005 to 2008. From there, perform full placebo tests for those 8 significant counties for the period 2005 to 2008 and analyze those results. In the results we'll show today, I look only at the year 2006. The effects do show up slightly differently in different years, but we have to keep the talk to 20 minutes today. One of the things here to note is the timing is crucial. Too early and that score will be lower, your delta TR will be reduced. and too late, and the effect will be absorbed. And I've got a couple of slides here to show that. So this is an example of what happens if the treatment timing is wrong and you choose too late a treatment time. So this is our base case, 2006. The black line is the actual population change, and the gray is the synthetic control. And if we move out to 2009, we start to see the effect being absorbed, and by 2013. And so if we use the timing of the C8 science panel results, when there was sort of real community knowledge, there's a firm answer, then the effect has already been absorbed. So this is a summary slide of our results. We'll get into some details of these. So the top counties are directly impacted. They had a water district where PFOA was found in the water. The other counties at the bottom were counties that were included in the C8 science panel study. The results I'm going to show you guys today focus on the directly impacted counties. One exception, I wanted to show you guys what a no result looks like. So this is Jackson County. Jackson County was notable in that it is bordered on 3 sides by directly impacted counties, but does not use any contaminated water source for drinking, and did not have any waste dumped in their landfills. So Jackson is sort of a, when there's nothing to see, how well did the model do at predicting, and that's what I'm showing you here. So we'll start with Washington County. It's directly across the river from the Washington Works plant and had 2 impacted water districts. In summary, we see a pretty significant population change effect between 1,300 and 2,300 for the window that we focus in on 2005 to 2007. The graph is for 2006 specifically. Wood County, which is Parkersburg and West Virginia and the home to the Washington Works plant. Wood County has good fundamentals relative to what we think about for population loss. It's an urban area, high educational attainment. The models say the county is forecasted to grow and instead declined. And the decline is pretty steep here for a town of this size. So we see a population effect between 2,200 loss and 4,100 loss in that same time period. And then another one that's notable, Athens County, Ohio. Athens has a large public university, Ohio University, and the university enrollment grew by 3,500 in the period from 2006 to 2017. The total county grew by 2,300. So what's notable in our result here is the county grew, but not as much as might have been expected or forecasted. So when we put all of the counties that have a significant effect in our directly impacted counties together and think about it as a region, we find that overall the region's population grew less than expected. The models forecast a loss of between 5,800 and 7,400 fewer people than you might have forecasted in a total population of about 260,000. So we wanted to put some sort of economic impact to that, and as a crude tool, we use an estimate of a per capita income of $25,000 a year per resident, which is less than any county in the sample, and then we aggregate those effects from the period of the spill from 2005 or 2006 through to the end of our study in 2017. And where we land is aggregate income impacts between 800 million and 1.4 billion lost from the region. And that's in comparison to settlements and fines for the region of, 105 million in class action settlements, 10 millions in fines from the EPA. So an order of magnitude difference in the cost to the region in terms of population loss versus the punitive fines and settlements. So the conclusion of this, the impact of imperfect information is significant. The most significant population impacts occur prior to the release of the C8 science panel findings. Those effects do not happen uniformly in time, but over a range from 2005 to 2009. We think that speaks to how information moves through the community, how folks may have received their settlements, things like that. We developed a scoring approach to better identify when the treatment effect occurs based on the maximum difference in difference and a minimum prediction error. And the sort of best year for that is 2006, which is what I've shown you today. And overall, the impact of water pollution is larger than the pure environmental cleanup impact. So in this case, again, we estimate up to 1.4 billion in pure income effects versus 120 million in fines and settlements. So what is the cost of this regulation or of not effectively managing this regulation? And one of the things that's big here, and you see in a lot of the disaster literature generally, is that fear and distrust of the government response may drive population changes. And we see something here that seems to support that the information on the actual health effects was not clear at the time that we see the highest population impacts. And that's where I'm at. Thank you, guys.
All right. So first of all, thank you, Sam, for this this interesting work. I want to begin, I guess, by asking a straightforward question, not having a detailed paper to react to.
Sure.
When you were constructing your synthetic cohorts, what kind of concerns or weight was given to the impacts of the Great Recession, which happens coincidentally with the period of study that you're looking at? Also know that this part of West Virginia and southeastern Ohio is heavily energy dependent in terms of its economy, and there's fluctuations in oil prices during this time as well. So that's my first question, is how are those kinds of things handled or controlled for in constructing your synthetic cohort?
Sure thing. And actually, if you're interested in seeing a copy of the draft paper, I'd be happy to share with you just for future discussion. In the construction of synthetic, the biggest thing that addresses what you're talking about here is we include industry compositions, as well as some other things for, per capita incomes and unemployment rates, labor force participation rates, those kinds of things in the construction of the synthetic as a way to kind of directly go at that. And the other thing, as we work through this range of years, if I'm looking at 2005, then all my years prior to 2005 are used in my matches. But if I move forward, I add additional years. So 2008 includes years up through 2007, for example.
Got it. Okay.
So the idea being that you capture some of these effects that may be moving in time, including the recession is a big one.
Yeah, yeah. I guess two comments that you might want to think about, and again, they may be addressed in more detail in what you've already written. But one is, with the exclusion of other West Virginia counties and other Ohio counties, the Marcellus and Utica shale deposits and the development of those are largely excluded as well, except, I guess with Pennsylvania, there's a possibility of some matching happening there. So that again, just at first blush, that would be a concern I would have, is you're missing maybe some of the best matches for some of those counties by doing that. The second comment that I would say, again, something to think about, is when you report your results as a loss of income, I'm wondering, since most of the counties, and again, the exception, I guess, would be Athens County is actually having growth, but the other counties were predicted to lose employment or population. And so I'm wondering if you might want to do a net calculation as opposed to a total loss, or maybe that is what you did, but maybe it needs to be clarified, so that it's not, some of the employment or some of the population loss was going to happen anyway. Maybe that gets excluded from that income calculation.
I'm following you. So the net is sort of baked in, but if it wasn't clear,
Okay.
make that clear. So we're comparing the actual loss against the synthetic, which has some of that kind of baked into it.
Okay.
So we are apples to applesing them there in
Okay.
versus a different baseline, but that's a good get if that wasn't clear.
A secondary effect, I'm curious. So my background is actually on the economic development side of things. And so my bias here would be that I'd be curious to know how the early years of the settlement and the EPA fines impacted employment at this particular facility, and how that affected population. So typically from an economic development perspective, we would assume jobs drive population. And so if there's a huge job loss in the region, that would and so I guess what I'm saying is I'm wondering if your hypothesis is this is an information mismatch. I'm wondering if it's maybe more of a lot of those early years population decline had to do with lost employment opportunities.
I can speak for that for the plant we're talking about. That is something that's come up in previous reviews of this, that it's tough to back out for other places. The Washington Works plant, even up to this last year, has never had a major announced layoff or reduction in force through the whole period. So if there was job loss, and we've been trying to find data that could tell us something about that, it was not in sort of a big event. It would have been, a slow, kind of sneaks under the local newspaper sort of thing.
Right. Do you know if, and this is my ignorance of this region of West Virginia, could the affected quality of water impact other possible job opportunities? So are there other water intensive businesses in that region that would have been impacted by this contaminated water?
Other than the sort of employee, people drinking it aspect, it doesn't seem to have much of an effect. Again, the concentrations they're talking about for health effects are in the parts per trillion range. Mm-hmm. So it doesn't seem to have much effect on process, chemical process water type things. It seems to be pretty isolated to a health effect, which is what makes the study pretty interesting. I've got some concurrent work that looks at the MCHM spill in Charleston a few years before that, which was a lot more acute, like you're talking about. You couldn't use the water for, drinking or anything.
Agriculture.
It was pretty nasty stuff, and it smelled bad and everything. And you see a very different type of effect from that one than you see here, where it's, it's just, it's all sort of, background noise about, well, maybe there's something wrong with the water, as opposed to, do not drink warnings. So, yeah.
Cool. Well, so, I thought this was an interesting study, interesting way to approach it. In terms of giving an economic take on an environmental issue, which is something we've struggled with. So I appreciate your work, and wish you the best in terms of getting it published and continuing this work.
Thanks for the time. I appreciate it.
Thank you, Dave. Are there any questions from the participants? If not, I'd like to thank the presenters today and the discussants for participating with us. And we plan to have another virtual session in the coming month. So keep on the lookout for any announcements for that. Also like to thank Kristen Devlin and Penn State and NERC. What's the acronym?
NERCRD, Northeast Regional
Right,
Center for
that's
Rural
our
Development.
tree to pull. Thank them very much for allowing us to use their platform. So everyone take care and see you later.